Welcome to statistics. This is the second year that I've taught this class, and I absolutely love statistics. And in an effort to make this video as short as possible, I'll spare you all the details of how much I really do love statistics and how I constantly tell everyone in my life about their statistical chances of something. So having said that, this is the presentation version that you're looking at. It's a PDF file of a PowerPoint. And if you were in class and I was showing you the PowerPoint, I would be clicking on things and things would be appearing and they wouldn't be all on the screen at once. So a lot of times as I scroll through, you're going to see answers already written on my slides that aren't on yours. They need to be on yours, but that wouldn't automatically appear if we were in class. So you're going to kind of see the answers before we get to talk about them. But hopefully as we go on, you'll get more used to it. Okay, so we're going to start with chapter 1, and chapter 1 is all about data collection. And our first section that we're going to talk about is 1.1, and that's the introduction to the practice of statistics. So in the beginning of every lesson, there's going to be a list of objectives, and for this lesson, we have 5 objectives, and that's first objective is going to be to define statistics and statistical thinking. Our second objective is going to be to explain the process of statistics. Our third objective is going to be to distinguish between qualitative and quantitative variables. Our fourth objective is going to be to distinguish between discrete and continuous variables. And our fifth one is going to be to determine the level of measurement of a variable. There's a lot of definitions inside of this particular section. I promise as we go on, it's going to get more interesting, but this is kind of the basis for everything. So again, you can stop this video, you can pause it, rewind, do whatever you need to do to make sure that your note packet has all the information that is on the screens that you're going to see. So for our first objective, to define statistics and statistical thinking, statistics is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusion. Data are fact or proposition used to draw a conclusion or make a decision. Data can describe characteristics of an individual. A key aspect of data is that it varies. And in fact, data vary when measured on ourselves as well. And one goal of statistics is to describe and understand sources of variability. Okay, and we're already through objective number 1. Objective number 2, we're going to explain the process of statistics. Okay, so the entire group of individuals to be studied is called a population. Okay, and an individual is a person or an object that is a member of the population being studied, and a sample is a subset of the population that is being studied. Descriptive statistics consist of organizing and summarizing data, and descriptive statistics describe data through numerical summaries, tables, and graphs. A statistic is a numerical summary based on a sample. So here's the one thing that I always like to say. Statistics starts with the letter S, and so does the word sample. So anytime you see the word statistic, you should immediately think sample. S. Inferential statistics uses methods that take results from a sample and extends them to the population and measures the reliability of the result. A parameter is the numerical study of a population. So anytime that you see population, you should think parameter. So parameter, population. And again, the word parameter starts with P, and so does the word population. So to statistics, sample, SS. Parameter, population, PP. So let's talk about some examples so you can see the difference of exactly what a parameter and a statistic are. So suppose that the percentage of all students on your campus who have a job is 84.9%. Okay, in this particular case, this value represents a parameter because it's a numerical summary of a population. Because again, you're talking about all the students on your campus who have a job is 84.9%. So that's going to be parameter population. But now, suppose a sample of 250 students is obtained, and from that sample, we find that 86.4% have a job. That value represents a statistic because it is a numerical summary based on a sample. So again, the word sample is clearly in there, but again, you took 250 students out of the entire student body. So it's only a sample of them. Okay, so here's our process of statistics and kind of a summary of even how this class is going to run. So the process of statistics, first thing that we're going to do is identify the research objective. A researcher must determine the question or questions he or she wants answered. The questions must be detailed so that it identifies the population that is to be studied and the question or questions that are to be answered. The second thing that we're going to do is collect the data needed to answer the questions that we posed in number 1. Gaining access to an entire population is often difficult and expensive. When conducting research, we typically look at a sample. The collection of data step is vital to the statistical process because if the data are not collected properly, then the conclusions drawn are meaningless. Do not overlook the importance of appropriate data collection process. We're going to discuss this step in detail in the coming sections of the rest of this chapter, in sections 2 through 6. Describe the data. Obtaining descriptive statistics allows the researcher to obtain an overview of the data and can provide insight as to the type of statistical methods the researcher should use. We're going to discuss that step in detail in chapters 2 through 4. And then the last thing is to perform an inference, and that's really how we look at statistics really in a meaningful way in an everyday life. We're going to apply the appropriate techniques to extend the results obtained from the sample to the population and report a level of reliability in the results. We discuss these techniques for measuring reliability in chapters 5 through 8, and inferential techniques are discussed in chapters 9 through 15. We don't get up to 9 through 15, so we're not going to talk about the inferential part, but we are going to talk about the measures of reliability from the chapters 5 through 8. So illustrating the process of statistics. So this is going to be an example again, and we're just going to talk about what each one of those steps would look like from that above slide. Many studies evaluate batterer treatment programs, but there are a few experiments designed to compare batterer treatment programs to non-therapeutic treatments such as community service. Researchers designed an experiment in which 376 male criminal court defendants who were accused of assaulting their intimate female partners were randomly assigned into either a treatment group or a control group. The subject in the treatment group entered a 40-hour batterer treatment program, while the subjects in the control group received 40 hours of community service. After 6 months, it was reported that 21% of the males in the control group had further battering incidents, while 10% of the males in the treatment group had further battering incidents. The researchers concluded that the treatment was effective in reducing repeat battering offenses. So let's break that down. Okay, so step 1, again, is to identify the research objective. So what was the research objective in that previous example? To determine whether males accused of battering their intimate female partners that were assigned into a 40-hour batterer treatment program are less likely to batter again compared to those assigned to a 40 hours of community service. The second step was to collect the information needed to answer the question. So again, based on that last example, what happened? The researchers randomly divided the subjects into 2 groups. Group 1 participants received the 40-hour batterer program, while Group 2 participants received 40 hours of community service. 6 months after the program ended, the percentage of males that battered their intimate female partner was determined. So step 3 is to describe the data, organize and summarize the information. So again, based on that example, the demographic characteristics of the subjects in the experimental and control group are similar. After 6 months of treatment, 21% of the males in the control group had further battering incidents, while 10% of the males in the treatment group had any further battering incidents. And then the last step, and again, probably the most important, is to draw conclusions from that data. So we can extend those results of the 376 males in the study to all males who batter their intimate female partners. That is, males who batter their female partner and participate in a batterer treatment program are less likely to batter again. And that's through objective 2. And here we are on to objective 3, and where we start getting into some more things that you'll start to have to identify when you get into your classwork. So objective 3 is to distinguish between qualitative and quantitative variables. So hopefully during algebra, whether that was last year, 2 years ago, whenever it was, you talked about qualitative and quantitative variables. Okay, first, variables are characteristics of the individual within the population, and variables vary. Example, height. So again, my height can vary from my age, or my height can vary from me to another person. Okay, as researchers, we wish to identify the factors that influence variability. So here we go with our qualitative and categorical variables. Okay, qualitative or categorical variables allow for the classification of individuals based on some attribute or characteristic. So again, if you look at the word qualitative, really in the beginning there, you see the word quality. Okay, so really anything that's qualitative is going to describe a quality. For a quantitative variable, that provides a numerical measure of an individual. Arithmetic operations such as addition and subtraction can be formed on the values of a quantitative variable that provide meaningful results. So this, in the beginning of this, you can almost see the word quantity. Okay, so we have a quality and a quantity. So anything in general that you can put a number to is going to be quantitative, and everything else is going to be qualitative. There's only one difference though. If you have something with numbers, again, you have to be able to perform an operation on them that makes sense. So what would be something of an example of something that you could put a number to? We just talked about height before. So height is a number, and again, we can add or subtract heights. I can say that I'm 2 inches shorter than the teacher next door. You can say that you're a half a foot taller than your younger sibling, so on and so forth. So we can pair heights and it makes sense. So when would we use a number that we wouldn't perform an operation on, or that wouldn't make sense in terms of addition or subtraction? The number on the back of your football jersey. If I look at the number on the back of your football jersey and it's the number 75 and the person next to you is 76, we don't ever compare those two numbers and say, oh, he's one number more or less in any sort of meaningful way, shape, or form. We never add those numbers together. We never subtract them. So that would be a case of where a number actually represented a qualitative value. And if you think about your a bank account number, same thing. I have my bank account number, you have your bank account number. Never ever would we look at our two bank account numbers and be able to draw a conclusion from them. I would never say mine is 1,000 digits off from yours. I would never add them together to come up with a new account number that would mean anything else. So that would be an example of a number, again, that's actually qualitative. But in general, quantitative, anything that you could put a number to. Qualitative is a quality. Okay, so again, spoiler alert, the answers are already shown, but let's go through this. So we're going to distinguish between qualitative and quantitative variables. So researcher Elizabeth Kavik and others studied factors that affect the eating habits of adults in their mid-30s. Classify each of the following variables considered in the study as qualitative or quantitative. Part A, nationality. Nationality, again, you can't put a number on that. That's qualitative. Part B, the number of children. You absolutely can put a number on that. I have 2 children. I have 3 children. I have 4 children. I have 3 more children than you. That's quantitative. Household income in the previous years, again, quantitative. Put a number to that. Your level of education, I can't put a number to that. I don't say I have a level 2 education. That's going to be a qualitative. And your daily intake of grains measured in grams per day, again, because you're measuring them in grams, and I can say I had 4 grams of something, that's going to be quantitative as well. So objective 4 is going to be to distinguish between discrete and continuous variables. Okay, a discrete variable is a quantitative variable that has either a finite number of possible values or a countable number of possible values. The term countable means that the values result from counting, such as 0, 1, 2, 3, and so on. So if we were in class and I wanted to count the number of people that were in class, again, that would be a discrete variable. I start counting 1, 2, 3, and eventually I'm going to get to the end of the number of students in the class. It's not going to go on forever. A continuous variable. A continuous variable is a quantitative variable that has an infinite number of possible values that it can take on because it can be measured to any level of accuracy. 2 dogs, Bourbon, Scout, they have no idea why they're barking right now. Scout, shh. No one wants to hear your mouth. I can't pause this video because if I pause, I can't restart. So we'll just deal with them for a sec. They'll be quiet eventually, I promise. So a continuous variable, again, can have any number in between. So if you were to think about like drinking a glass of juice, your glass of juice might start out with 8 ounces, but as you drink it, you can end up with any value between that 8 ounces and the 0. You could have 7.9 ounces. You could have 7.94 ounces. You could have 6.2139 ounces. So any number in between, that's going to be a continuous variable. So again, now we're going to look at that same research from the one above where we study the factors affecting eating habits of adults in their 30s. But now we're going to classify each of the quantitative variables as discrete or continuous. Again, when you're talking about discrete and continuous, it has to be a quantity because again, you're talking about numbers. So it can't be a qualitative value that you're looking at. It has to be a quantitative. So for part A, your number of children, that's discrete. Again, why? Because I have 0, 1, 2, 3. I don't have an infinite number of children. I can't have 1.2 children, so it's discrete. Household income in the previous year is continuous. Again, because it could be any number from $50,000, $50,025, $50,124.37. It could be any value. And for part C, your daily intake of whole grains, again measured in grams per day, again is going to be continuous. Not that you're going to eat an infinite number of grams, but again, it can take on any value between 0 and let's say your intake was going to be 50 grams. So it could be 0, it could be 1, it could be 1.2, it could be 10, it could be 10.69458. So if it could be any number in between, it's continuous. And our last objective is to determine the level of measurement of a variable. So there's 4 levels that we need to know about. So a variable is at the nominal level of measurement if the value of the variable name, labels, or categorizes. So in addition, the naming scheme does not follow for the values of the variable to be arranged in a rank or a specific order. Okay, so nominal is really naming only. Add that up here. Okay, and a variable is going to be at the ordinal level of measurement if it has the properties of a nominal level of measurement, and the naming scheme allows for the values of the variable to be arranged in rank or a specific order. So if I start talking about Mr. Lynham and Mr. Blum, they're naming only. But now if I want to talk about them in a ordinal sense, Mr. Lynham is the principal, Mr. Blum is the assistant principal. That would be an ordinal level of measurement. So these two values are going to be qualitative. Okay, and then for the next one, a variable that is an interval level of measurement, if it has the properties of the ordinal level of measurement and the differences in values of the variable have meaning. A value of 0 in the interval level of measurement does not mean the absence of a quantity. Arithmetic operations such as addition and subtraction can be performed on the values of the variable. So an example of something that would be an interval level of measurement might be temperature. Okay, we can make sense out of differences in temperature. In other words, I can say 70 degrees is 10 degrees warmer than 60 degrees. So again, you're making sense out of that number there. But here, the value of 0 doesn't mean the absence of something. So in 0 means the absence of heat. Sure, it absolutely does mean that there's an absence of heat. However, we could also argue that there's an absence of heat when it's 30 degrees out. So 0 doesn't necessarily mean the absence. So an interval level of measurement, again, might be something like temperature. A variable that is at the ratio level of measurement, if it has the properties of the interval level of measurement and the values of the variable have meaning. A value of 0 in a ratio level of measurement means the absence of a quantity. Arithmetic operations such as multiplication and division can be performed on the values of a variable. So anytime that you can have something that doesn't exist, it has a value of 0, it makes sense, that's going to be a ratio level. So these two are quantitative. So we have our qualitative and our quantitative. So the last thing that we're going to do is we're going to do one more example, and we're going to look at the levels of measurement in them, and then that will be it. So determining the level of measurement of a variable. A study was conducted to assess school eating patterns in high schools across the United States. The study analyzed the impact of vending machines and school policies on student food consumption. A total of 1,088 students in 20 schools were surveyed. School lunch and snacking patterns among high school students association with school food environment policies. The International Journal determine the level of measurement. That's what we're going for. I'm trying to not say as many words here. I'm trying to make this video as short as possible, so bear with me. So determine the level of measurement of each of the following variables in that study. Okay, so the number of snacks and soft drink vending machines in the school, first of all, it's a number, so it either has to be interval or ratio. So now we have to decide if 0 makes sense. Would it make sense if you had no snacks or soft drinks? Absolutely would. Therefore, that's a ratio. For part B, whether or not the school has a closed campus policy during lunch, that's nominal. First of all, you can't put a number to it, so it either has to be nominal or ordinal. And nominal, it's naming only. Ordinal, again, would have to have an order of first, second, third. And we're not ordering it from best to worst or anything like that, so it's nominal only. For part C, class rank, freshman, sophomore, junior, or senior. Again, you can't put a rank for sophomore, junior, senior in terms of a number. So that's got to be qualitative. So again, it either has to be nominal or ordinal. And this time, because you're ordering them in a specific order, that's going to be ordinal. And for part D, the number of days per week a student eats lunch. Again, we can put a number to that. So it has to be either interval or ratio. And again, we need to decide if the number 0 makes sense. Okay, so could a student eat lunch 0 days per week? Sure. They might not eat lunch in school. They might skip lunch. So 0 does make sense. So again, if 0 makes sense, that means that one has to be a ratio. Tomorrow when we're in class, we're going to do the classwork from this section. Hopefully my dogs won't bark during the next video.